The last two videos were talking about solving systems of inequalities and equations by graphing, and now we're going to look at solving systems of equations and inequalities algebraically by a method called substitution. The substitution method can be broken down into three simple steps. Step 1, solve one equation for one of the variables. Step 2, substitute your answer from step 1 into the other equation to replace the variable, then solve that equation. Step 3, substitute to solve for the other variable. Pause the video and take a minute to write this down. So now let's use those three steps to do a problem. So we have the problem 5x minus 3y equals 23 and 2x plus y equals 7. This is a system of equations. And so the first step is to solve one equation for one of the variables. So I look at both of my equations and I look for one of the equations that make it easier to solve for a variable. So if I'm looking, I notice that the y is alone. That's beautiful. So I'm going to take that equation, this one right here, and solve for y. So I'm going to take 2x plus y equals 7 and solve for y. Okay, so I get y equals negative 2x plus 7. Now, that's step 1. Step 2 is to substitute this equation that we just made into our other equation. Okay, so what that means is we now have something that is equal to y. So we solve for y. So we have this part right here, right? Which is equal to y. So in the other equation, we can just substitute it in right here. So let's take a minute and do that. So if we have 5x minus 3, our y we know is equal to negative 2x plus 7. So I'm going to plug that whole thing right here, negative 2x plus 7 equals 23. Now if you notice, in this equation now, we have no y's. We have gotten rid of our y's, which is beautiful because if we're solving for one variable, we only need one equation. So we have one equation now. So now I'm going to solve for x. So I'm going to bring down the 5x minus, now we have 3, and we're going to distribute, we're going to use the distributive property and distribute into our parentheses. And so we have negative 3 times negative 2x, which gives us a positive 6x. Negative 3 times 7 gives us a negative 21 equals 23. Then we can combine like terms. We have this 5x and the 6x. We can combine them because they both have the same variable with the same power. So 5x plus 6x gives us 11x's minus 21 equals 23. Then we're just solving for x. So we need to get rid of the 21 on this side. So I'm going to add 21 because it's the opposite. What you do to one side, you got to do to the other. We're left with 11x equals 44. X is still not alone, so we need to do one more thing and divide by 11. Get x is equal to 4. So a lot of people stop here, but again, let's ask ourselves, what is the solution to a system of equations? And the answer is that it is a coordinate point that satisfies both of these equations. So it's a coordinate point. So we need an x value and a y value. So that's where step 3 comes in. So we're going to take this x value that we don't have the y value yet, and we can plug this into this. We could plug it into this one. We could plug it into this because they are the same. Or we could plug it in up here. I'm going to plug it in right here because it's easier that way. And so I'll take my x is equal to 4. We have y equals negative 2 times the 4 that we just found plus 7. So y equals negative 8 plus 7. Y equals negative 1. Boom. Now we have our x and we have our y. So our answer is 4, negative 1. So this right here is our coordinate point that satisfies both of these equations. So on a graph, it would be where the lines intersect, where they meet. Okay, so if we wanted to check this, let's go ahead and try that. It's important that we always check our answer to make sure that we did the right steps the whole time. So we can take our first equation, and we're testing this point down here for negative 1, making sure that our left-hand side is equal to our right-hand side. So we'll take 5 times 4 minus 3 times a negative 1 equals 23, and we're asking, is this correct? Okay, we don't know yet, so it's a question. So 5 times 4 is 20. Negative 3 times a negative 1 is a positive 3 equals 23. Do we know yet? 23 equals 23. Boom, that's true. So now we know that this point is definitely on this line. It is a solution of this. Okay, now we have to just check if it is also on this line and a solution of this. So let's plug it on in. We have 2 times 4 plus 4. Oh, whoa, something's wrong. Okay, this is really supposed to be a y. Can't read my own handwriting. So this is a y. Surprise, it's a y. Okay, equals 7. So that y, if we do 2 times 4 is 8, plug in the y, which is a negative 1, equals 7. We're asking ourselves, is this true? 8 minus 1 is 7, equals 7. Boom, that's true. Therefore, this is the answer. So here's another example. X minus 7y is less than 11. 5x plus 4y is greater than or equal to negative 23. So when we're dealing with inequalities, we can't find the entire solution just algebraically, because if you remember, with inequalities, we're shading a section of the graph, and in that section there's a ton of points. So you're not going to want to find every single point, because it's anything that's in that shaded area. So, but what you can find is their point of intersection, which is typically in real-world scenarios, typically the most important part is the intersection points. So what you're going to do is take these inequalities and just turn them into equations for right now. So we're going to turn it into x minus 7y equals 11, and 5x plus 4y equals negative 23. And that's just for the time being, just so we can find the point of intersection. So one of their solutions. So if we're doing our substitution method again, our first step is to solve one of the equations for one of the variables. So if we're taking a look at these over here, I'm going to look at my equations and find something that looks probably like just a variable that only has a 1 as its coefficient, because it's easier to solve for. So we're going to take this equation, because it's beautiful, and solve that for x. Okay, so we have x minus 7y equals 11, and we're going to solve for x. So x equals 7y plus 11, because we added 7y to both sides to get rid of that 7y. Cool, so now we have that x equals 7y plus 11. And those are the same equations because we just moved them around. So now we're going to, step 2, substitute this result into our second equation. Okay, so we're going to take 5y. 5 times 11 is a positive 55. Bring down the 4y equals negative 23. Then we can combine like terms. We can combine this term and this term because they both have a y with the same power. So if we have 35y's and 4y's, we have 39y's plus 55 equals a negative 23. And we haven't solved for y yet, so we need to do that. If we subtract 55 from both sides, 39y equals, I think it's a negative 78. Yep, negative 78. And then we still don't have y alone, so we're going to divide by 39. Divide by 39. And we get y is equal to negative 2. But we're not done yet. We have to take this y and plug it into our equation because we have to find a coordinate point because our solution is a coordinate, correct? So we need an x and a y. We have our y. Now we need our x. So I can take this right here and plug it into this. And I'll get that x equals 7 times negative 2 plus 11. X equals negative 14 plus 11. So x is negative 3. So now we have both our x and our y. And we will write it like this. Negative 2 or negative 3, comma negative 2. And now we need to check to make sure that we are correct. Okay, so now we're checking to see if our point is a solution of both of the equations. So we have our first equation, and we're going to go ahead and plug in our x for our x. So negative 3 minus 7, we put our y in where our y is. Negative 2 equals 11. We're asking ourselves, is this true? So negative 3, negative 7 times a negative 2 is a positive 14 equals 11. Negative 3 plus 14 is 11. 11 equals 11. That is a true statement. Beautiful. Now we're going to do the same with the other side. We have a 5 times negative 3, because that's our x, plus 4 times a negative 2, because that's our y, equals a negative 23. 5 times negative 3, negative 15. 4 times negative 2 is a negative 8. Oh, we're asking ourselves, is this true? A negative 23, is this true? Negative 15 minus 8 is negative 23 equals negative 23. Boom, that's true. Therefore, we know that this is our answer. So again, just a reminder, when we're talking about inequalities and we want to solve by substitution algebraically, you can only find the point of intersection, and then you'll have to look at the graph for all the other points and for the shaded region. Whereas if we're just solving a system of equations, it's going to just tell us our points of intersection. So I want you to try this problem on your own. This is a system of equations, and I want you to find the solution. So find the solution. Okay? So I'm going to be checking this tomorrow. This problem done and your notes is how you're going to get your stamp for the day. So make sure you try this. I want you to look through, go back to how to do the substitution method, those 3 steps, and work through it.